In this problem, there is a vertical spring which is compressed 0.13 meters and weighs 2 kilograms with a spring constant of 1040 newtons per meter. The question is asking if the 2 kilogram ball is placed on top of this spring, what speed will the ball have after it's released, and how high, the second part is how high above the original position the ball is going to travel. So for the first part, as always, initial energy plus or minus work done is equal to your final energy, and there's no work done in this problem. The initial energy is 1/2 the spring constant x squared, because it's spring potential energy, and it's going to end up having kinetic energy 1/2 mv squared and gravitational potential energy, which is mgh. For this problem, you're going to have to solve for v, so you're going to subtract mgh to the other side. So you have 1/2 kx squared minus mgh equals 1/2 mv squared. After this, you're going to have to divide by 1/2 and the mass, and take the square root of that. So because we have a 1/2 over here, you're just going to end up having kx, that's a k, kx squared over m minus 2gh equals your final velocity after you square rooted it. So you end up having 1040 times 0.13 squared over a mass of 0.2 minus 2 times 9.8 times 0.13 equals your final velocity, and that final velocity ends up being 9.24 meters per second. The next section asks how high above its original position the ball is going to fly. So you're going to have to calculate the gravitational potential energy after the spring energy. So you have 1/2 kx squared, which is your initial energy, again no work is done, equals mgh, which is your final gravitational potential energy. So you end up dividing by mg, so you have kx squared over 2 mg is equivalent to your height. So you have 1040 times 0.13 squared over 2 times 0.2 times 9.8 is going to equal your height, which is 4.8 meters.